Hi, this is Mr. Rutherford. In this problem, we will look at a real-world example. The table shows the temperature of a solution after it has been removed from a heat source. Find the rate of change in temperature for the solution. Here it says we need to find rate of change. Rate of change is equal to the change in Y divided by the change in X. In other words, we have here the slope. And slope is equal to y2 minus y1 divided by x2 minus x1. So when we're finding the slope or rate of change, we need to have two ordered pairs. So let's choose two ordered pairs. Notice in the table we have time 0, 2, 4, 6, and 8 minutes. And here we have temperature 156.9 through 128.5 degrees Celsius. So each of these constitutes an ordered pair. So we need to choose two of these. Let's choose the 2 148.4 and the 4 142.8. Before we actually find the slope, let's notice here that the temperature is decreasing as the minutes increase. This means we should have a negative slope. So, our ordered pairs we said are 2 148.4 and 4 142.8. So now let's label these with our x1, y1, and x2 and y2. So our 2 will be our x1, and our 148.4, or 148.4 rather, will be our y1. The 4 will be x2, and 142.8 will be y2. So now we can substitute these values into our slope formula. So we have slope, or rate of change, as we said before, is equal to our y2, which is 142.8, minus y1, which is 148.4, over or divided by x2, which is 4, minus x1, which is 2. Now let's simplify both the numerator and the denominator. If we subtract 148.4 from 142.8, we get a difference of negative 5.6. 4 minus 2 is 2. So now if we divide these, or simplify this fraction, we have negative 2.8 over 1. Or in other words, our slope or rate of change is equal to negative 2.8 degrees Celsius for every minute that we increase. And remember we said in the beginning, we notice a pattern here that our temperatures were decreasing as the minutes increased, and we said that our slope or rate of change should be negative. Notice we did get a negative 2.8 degrees Celsius. So now you've learned in a real-world example to find the rate of change.